Welcome to today's physical science lesson. My name is Mashidu Mamboro. This lesson is brought to you by the Gauteng Department of Education in collaboration with Cybono Discovery Center. Today we'll be focusing still on the topic of matter and materials. Remember, matter and materials has plus minus 58 marks on the paper 2 question paper. So you know there are a lot of marks that you are supposed to collect here. We are making sure that you have understanding. Reactions, if you check, is the question that is mostly failed, or learners are not doing too well on reactions. Hence, we'll be doing the revision on reactions, and we are hoping that you will understand. You will be doing questions, you will have understanding, and you will have more confidence as you write your exams or your control tests. You will be able to write and pass. And then, if you check, you will see that reactions are on question 4, which is 49% for last year, 2024, 49%. But you can see the other topics we're doing well. But the main thing is that organic molecules, if you get more marks in organic molecules, you will be able to do well in paper 2 as a whole. Now, so we'll be focusing on the reactions, which is the last topic for this term. And then we'll be dealing mostly with problem solving. So we are focusing on strategies to say, how do I go about solving these problems? So if you look there, we have activity 1, which is a multiple choice question. And we are saying when you have a multiple choice questions, you are given 4 options. You must read the statement with understanding, and you must remove at least 2 distractors or questions that are options that are obviously wrong, and then remain with 2. Because you are increasing your chances, you will have 50% chance of getting the answer correct. So always do that. Remove the options that are obviously incorrect. Now let's look at this one. They are saying a test tube contains a liquid hydrocarbon. When bromine water is added to the test tube, the mixture decolorizes immediately. So that is the first statement. So you are able to see there that we have a hydrocarbon, we have bromine water. Which one of the following combination correctly identifies the compound and the type of reaction that takes place in the test tube? Now, what you have to understand now is that now you are having compounds, you are having the type of reaction. So the first compound that we are given as option number A, they are saying is hexane, and the reaction is addition. And you know very well that alkanes, they don't undergo addition. Alkanes, haloalkanes, and alcohols, they undergo substitution and elimination. So when you see alkanes, haloalkanes, and alcohols, you know they will undergo either substitution or elimination, and then oxidation as well for alkanes. Now we are saying hexane is an alkane, so it cannot undergo addition. Remember, addition is only the unsaturated hydrocarbons that we do their reactions. We focus on alkenes. So alkenes are the ones in grade 12 that are undergoing addition reaction. So you will see that this one will be wrong because alkanes, they don't undergo addition. So that is an obviously incorrect answer. Let's look at option number B. It's saying hexane. Hexane can undergo substitution. Hexane can undergo substitution. Let's look on the option number C. It's saying X2-ene. X2-ene can undergo addition. X2-ene can undergo addition. But the last option, number D, is saying Hex2-ene, which is an alkene. And it's saying this alkene is undergoing substitution. So that is obviously wrong. So we're able to remove the answers that are obviously wrong. We're left with number B or C as our options. Now, this one where we have now the bromine water testing for the presence of a unsaturated hydrocarbon, that reaction is when we have an unsaturated hydrocarbon. We add the bromine water on the double bond there, and then the reaction is called addition. So you are able to see that that answer must be option number C, because we're checking the availability of unsaturated hydrocarbons. So we use the bromine water, and then we are saying there will be a color change from reddish brown color to color change. That's what we're expecting. So they said this bromine water is going to decolorize the mixture already. So you are able to see that definitely number C is our correct answer, and we use that to check the presence of unsaturated hydrocarbons. We use bromine water to check that, and we expect color to change from reddish brown to colorless. So our answer is number C. So you're able to see that alphabet C is our correct answer. Now let's go to 1.2 that says during the dehydration of butanol represented below, compound Y forms as one of the products. Remember, the word D means removal. D, we're removing. What are we removing? Hydration. So we're removing water. When we remove water here, which product will be formed? That's what this question is saying. Which one of the following is the correct condensed structural formula for compound Y? What will be formed when we remove water from butanol? That's what this question is saying to us. Now, you have now to always remember the rules that we use. We have rules that we use to say, we know we have two options. We are going to remove the OH, obviously. We're going to remove this OH, but we have an option of removing a hydrogen from carbon number 1 or a hydrogen from carbon number 3. So those are two options that we have. And according to Zaitsev's rule, we are saying we remove hydrogen from the carbon with the least number of hydrogen. So we said the poor becomes poorer here, which means the poorer carbon here, which is carbon number 3, is the one where we're going to remove the hydrogen. And then the one that is carbon number 1, when we remove that one, we'll get a minor product. We won't get a major product. So you got to have understanding to say always the living group, which is OH here, is the one that is supposed to live there. But we're saying it won't live alone for it to form water. Hence, we're saying dehydration. We're removing water. Which hydrogen will join the OH? We're saying we have the option of hydrogen in carbon number 1 and hydrogen in carbon number 3. And we are saying in our explanation to say the hydrogen in carbon number 3 is the one that will give us the major product, which is the most stable product. So now what is going to happen here is that we're going to remove the OH from this carbon and then the hydrogen from this carbon number 3. So we'll have a double bond between carbon number 2. And then that's what you can see already. When you go to our options, you are able to check to say when we eliminate, when we dehydrate, when we eliminate, we are forming a double bond. So you are able to see that the answer must have a double bond. And option number A, no double bond. Option number C, no double bond. Option number D, no double bond. So they are all incorrect. The only option is option number B, where a double bond is formed there, and we're able to see that that is the major product that is formed. If the double bond was in carbon number 1, it will have been a minor product. But for the major product, we're saying we remove the hydrogen. When we eliminate from the carbon that has the least number of hydrogens. I hope I've emphasized that, and then our answer there is B. Now 1.3. Which one of the following reactions takes place? Which one of the following reactions types can be used to prepare ethene? What can we use to prepare ethene from octane? Remember, octane is a 8 carbon, C8H, and then you say 8 times 2 plus 2, that is 18, C8 18. So that is octane. They're saying if you want to form octane, which one can help us to form ethene? Remember, we have to break down this large organic molecule into smaller, most useful molecules. And that process is called cracking. By definition, we are saying cracking is a chemical process where large hydrocarbons are broken down into smaller, most useful molecules. So we see that ethene will be prepared through a reaction called cracking, and then you are able to get your 2 marks. Remember, last year majority of our learners were unable to define what is cracking. So it's important that you know the definition of cracking. You will remember as well that cracking is a process. We are saying here during cracking we can form an alkane and an alkene. We can form an alkene and hydrogen, which we call dehydrogenation. So you are able to see those are the cracking processes, which is part of the elimination reactions. So during elimination, we are saying that you can have octane there, you can be able to crack it or to break it down to form an alkene, which is ethene. So the answer there is number C. I hope you are moving with me and you can see how to answer these types of questions. Now, with no any waste of time, I would like us to move to the next question, and then the next question, which will be on the NSC 2021 question paper. Now, the issue here was name the type of reaction represented by reaction 1, and then this is your example. Reaction 1, you are able to see that is reaction 1. So what is happening is that we're given compound P, which is used as a starting reactant in each of the reaction as shown in the flow diagram. So you are having your molecule here, which is compound P. So you are given C5H11Br, which now is able to undergo 2 reactions, which is reaction number 1 and reaction number 2. So the most important thing for you to have the understanding is to say, when you have compound 1, you are able now to say compound P. If we bring dilute sodium hydroxide, remember we said AHA, we said alkanes, haloalkanes, and alcohols, they are ones that undergoes 2 reactions. Is either they will undergo substitution or elimination. But we are saying we are aware that alkanes as well can undergo oxidation or combustion. But in this case, we're focusing on substitution and elimination. To say, when you see a haloalkane, you know that it can undergo substitution or elimination. So we're given a haloalkane, is either it will undergo substitution or elimination. I want you to have that understanding, so that at all the times when you see alkanes, when you see haloalkanes, when you see alcohols, you must know that they will undergo substitution or elimination. And then we're adding to say, when it comes to alkanes as well, they can undergo oxidation as well. But when you see a haloalkane, you know that a haloalkane will undergo substitution or elimination. And if you check there, we're given a dilute sodium hydroxide. A dilute sodium hydroxide tells you that now if it's dilute, there is what we call CEDS. For you to remember we're doing exam skills here. To say, if you are given concentrated sodium hydroxide, for example, you know that the reaction is elimination. It can be concentrated sulfuric acid or concentrated sodium hydroxide. When you see a concentrated something, you know that the reaction is elimination. But when you see a dilute, you know that the reaction is substitution. Hence we're saying says there, or CEDS, which means that concentrated is for elimination, dilute is for substitution. And if you check here, we have dilute. So already you will know that this will be substitution reaction. This one is concentrated. This must be elimination reaction. So you are able to see that the 2 reactions now, to say the other one is substitution, the other one is elimination. And then if you check the substitution, you will see that we were having a BR here, bromo there. And when you check on the product side, we are having 1 all there. We are having 1 all there that is given. So when you have 1 all there, you are able to see that we are having in carbon number 1, we are having OH, which is now the hydroxyl group, which is attached to in carbon number 1. The OH is attached to carbon number 1, and then that's why we're saying butan 1-ol. So you are able to see that we replaced bromine with OH in carbon number 1. We had bromine in carbon number 1. Now we have OH in carbon number 1. So you can see when we replace, you see that the reaction is what? Substitution. And what type of reaction? What type of substitution? Because you must know the reaction and the type of that specific type of that reaction. For example, we are saying the reaction is substitution because we substituted bromine with OH, with alcohol. Now we're saying what type, or what do we call that type of substitution? We call it hydrolysis. Remember that all the time, that the reaction is referred to as hydrolysis. Now when you look here, when we use the one that is now now concentrated, you see the reaction conditions are important because they tell you the type of reaction that will take place. If we don't know concentrated and dilute sodium hydroxide, you won't understand what type of reaction will take place. So I'm saying to you, please go and make sure that you understand all the reaction conditions that we are supposed to have. Now let's look at this one. We're going to have now, already you see that, the methyl is in carbon number 2. So it's a 2-methyl butan 1-ol. Because some of our learners, immediately when you see C5H11Br, you are thinking of pentane, to say, okay, it must be pentane here. Now you are learning something to say, as long as it's a molecular formula, we still have what is called chain isomers. So you see that it's not, this one is not 1-bromopentane. It must be in carbon number 2 we have a methyl. So it cannot be the first structure, the compound P cannot be pentane. It will be butane. In carbon number 1 we are having bromo. In carbon number 2 we are having a methyl. So you are able to see that the structure that we had now as compound P there must have been 2. You start with the bromine, which is you start with the bromo, which is in carbon number 1. So it will be 1-bromo, 2-methyl, 1-bromo, 2-methyl, butane. So this is the most important thing to say, that C5 does not necessarily represent a pentane. It can be an isomer of pentane. I hope you have understanding of that, to say in this case the 5 carbon were for 2-methyl and butane, because butane has 4 carbon. When you put 2 in carbon number 2, you put a methyl, the carbons becomes 5. So you are able to understand that that is 2-methyl butane, and in carbon number 1 we have a bromo, and then we were able to replace the bromo in position number 1. We replace the bromo with the OH, hence the suffix changed there to be butan 1-ol. So I hope you have understood that. And there was nice questions to say, name the type of reaction represented by 1, which is substitution, reaction 1. Why? Because we are using dilute sodium hydroxide. The next one was, is this a primary, secondary, or tertiary alcohol? And you were expected to give the reason. Now it's very much important to always check to say, okay, this type of alcohol, is it primary, is it secondary, is it tertiary now? So you are able to check to say, okay, if now the OH butan 1-ol is 1, 2, 3, 4. In carbon number 1 we have an OH, hence we're saying butan 1-ol. We're saying the alcohol part is in carbon number 1. Now you are able to have the entire structure, but we're saying in carbon number 2 we have a CH3 there. So you have to know that in carbon number 2 we have a CH3, so that would be 2-methyl butan 1-ol. But now we are focusing on the carbon that is bonded to the OH when we define primary, secondary, and tertiary. So we're saying this will be a primary alcohol. Why will it be a primary alcohol? It will be a primary alcohol because the carbon atom that is bonded to the hydroxyl ion or to the OH, to the OH is bonded to only one other carbon. This carbon that is bonded to the OH is bonded to the other carbon. And you can as well say the carbon that is bonded to the OH is bonded to 2 hydrogens. So that is acceptable when we do the marking. To say, you can say that the carbon that is bonded to the OH is bonded to two other carbons. So I hope you have that understanding, and then you know the difference between primary, secondary, and tertiary alcohols. And then the type of reaction. I've emphasized the importance of the reaction condition. To say the reaction condition is telling us what type of reaction is going to take place. We knew that this will be elimination. How did we know that? We knew that because already we see that this is concentrated. When it's concentrated, a strong base, we know it's elimination. When it's dilute strong base, we know is substitution. So go spend time understanding all the reaction condition. Now you can see that immediately when we have a double bond there, we're going to add, because on an alkene, compound Q will be an alkene because it's a product of elimination. When we eliminate, we form alkenes or alkynes. So we increase the number of bonds. But for grade 12, we are forming the alkenes. So we're simply saying as we eliminate the HBr there, which is dehydrohalogenation, we are saying that compound Q will be formed. It will be an alkene. It will be an alkene, and the alkene undergoes addition. What type of addition? Hydrohalogenation or hydropromination. So the type of reaction will depend on what you are adding. Will tell us the type of reaction, and then we'll be able to form a compound Q. Compound Q, which is what we are having. So it's very much important. The question was, write down the structural formula of compound P. So you are able to write the structural formula of compound P. And they are saying here, name the type of reaction represented by 2. Represented by reaction 2, we talked about it already, that it is elimination. So we've talked about this, that this is elimination. And what are we eliminating? HBr. So hence we are calling it dehydrohalogenation or dehydropromination, because it's HBr. So dehydropromination. And we are saying compound Q, we said is an alkene. Compound Q is an alkene. Why is compound Q an alkene? Because we're eliminating. How do we know that we are eliminating? Because we are using a concentrated strong base, which is used for elimination. So I'm singing one song to say the reaction condition must be your friend, must be close to you. You must know all the reaction conditions, because if you know the condition, you know the type of reaction that will take place. I hope that helps you as we move, and then you'll be able to do very well in terms of that one. Now, name the type of reaction represented by reaction 3. Choose from addition, elimination, or substitution. So we talked about that. To say reaction 3, because we're having an alkene here, is going to be addition. What type of addition? We said is hydrohalogenation or hydropromination. That is the addition that will take place there. And then the isotopic name of R will be 2-bromo 2-methyl butane. I hope you got all that, and it will help you as you continue to do these types of reaction. So if I'm to move forward, the reaction continued to 4.2. In 4.2, where you were given 1,2 dibromopropane that can be prepared from but-2-ene. We want to show you here that we have synthesis type of reaction, because it can't be all the time that we just give you things, you tell us what happened. Sometimes we give you stuff and say prepare. For example, here we are saying you must prepare 1,2 dibromopropane. You must prepare it from but-2-ene. You must prepare it from but-2-ene. So if you can think about that one, to say, how will I go if I'm given 1,2 dibromopropane? How will I go? And if I'm given but-2-ene, how will I go to prepare 1,2 dibromopropane? Now let's look at step number 1. Already you know that this is an alkene. And when an alkene is given, you know the type of reaction. Ours is the simplest here to say, when I see an alkene, I know it undergoes addition type reaction. So it means now I know that we're going to add on this alkene. We're going to add on this alkene. But what are we going to add? That is the question that you must ask yourself, to say, what are we going to add? Now, it is better when you come from this alkene, you come there, you say, okay, we want to form 1,2 dibromopropane, which means the number of carbons, they are no longer 4 when we reach where we're going. So somewhere on the road, we got to crack, we got to break down the structure, which means that we only do the breaking down of hydrocarbons, which are alkanes in this case. So compound A must be an alkane so that it can undergo cracking. So that is the thinking process that you will have. To say now we are having an alkene, which is butene. How can I form butane from butene? So you are able to look at that. To say, okay, we're given butene, we wanted to form butane. So it must be an addition type of reaction. So it must be addition type of reaction, and then we are adding what? Hydrogen. So if we add hydrogen on butene, you know we'll be breaking down the double bond. Remember, here we break the bonds. We break down the double bond from butene. When we add the 2 hydrogens on the butene, we're able to get what we refer to as butane. And when you have butane, butane will be able now to undergo a process that we call cracking. So we can crack butane and form propene and methane. Remember, when we say butane, we was talking about C4H10. So we're having 4 carbons. And the product that we want must have 3 carbons, which is propane. Hence, we're going to break down the 4 carbons in butane, which is now we're going to form methane and propene. Methane and propene. You see that we just gave you compound B there. We didn't give you CH4 because CH4 is another product that must be formed there. But we are interested on compound B, which is propene, that we can be able to now add. What must we add? We want to add 2 bromines there, which is dibromo, which means Br2. We're going to add Br2 on propene in order for us to get 1,2 dibromopropane. So I think you got that one, and you are able to see it, to say that, okay, we had a butene, and then we took the butene, we added 2 hydrogens to form butane, and butane, we said, is a C4H10. From that C4H10, we are saying that we don't want 4 hydrogens, 4 carbons, we want 3 in order to form propane. Hence, we're going to crack that structure. And we said when we do cracking, we form alkene plus alkane, alkene plus alkane. So you see that the alkene that will form from butane will be propene, plus methane. Propene plus methane. Propene is what? Is C3H. C3H. You are having this one will be CH4. Definitely CH4. And then this one will be C3H6. Because when you add them, they must give you that C4. So 3 plus 1 is 4 carbons. 6 hydrogens plus 4 is 10. So you see that we're having butane, we crack it into propene and methane. But we're going to add the Br2 now on the double bond. Remember, the structure of propene is this one. This is the structure of propene that we are having. So that is the structure of propene that we are having. Then now we want the 1,2 dibromo, hence we are adding Br2. Br2, you are able to add. Remember, when you are adding, we add on the double bond, which means now on carbon number 1, we'll have a bromo. On carbon number 1, we'll have a bromo, and carbon number 2 will have a bromo. So you see that now the hence we are saying this will form 1,2 dibromopropane. So that is how we went about to form that structure. And this type of reaction, we call them synthesis reaction. And if you look on this example that I gave you here, you can see that the questions, when they were asked, they were saying use condensed structural formula. use condensed structural formula. So it's important that you know all types of formulas that we have, because if you don't know condensed structural formula, you will write structural formula, then we are going to deduct marks for writing wrong formula that you were not asked. So now you are able now to write the structure. Propene is that structure. You are able to write it the way it is, and then you are able to do what needs to be done. You are able to do what needs to be done, and then the questions, you can answer all the questions. And then that is the question. It was in 4.2.4 where they said use condensed structural formula to write down a balance equation for step 3, and then you are able to have that a propene there in a condensed structural formula. So you don't write it like that as a structural formula. You will say CH3, then you will say CH, and then you'll say CH2. That is propene in a condensed structural form. So it's important that you always remember the formula, because if the question asks you to write a particular formula and you write a wrong formula, definitely you're going to lose marks. So know all types of formulas that we have, and then you're just adding the bromine there, and then you are able to get your product. I hope you have learned, you have seen what needs to be done. Okay. Now we have the activity there, which I will give it to you to do. Just do only question number. Okay, let's do 1 and 2. So I'll just give you 7 minutes or so that you are able to do that activity. And then this one is based on the stoichiometry, because we are saying that you learners have more challenges in terms of solving this type of questions, and we expect that you will find stoichiometric questions even on organic molecules. So it's important that you learn even how to do this type of questions. So I'll give you to do number 1, and then you will do number 1, then we'll go and do the solutions. So we'll meet just in 7 minutes time when you are done with number 1 and number 2. Welcome back. Hoping that you have dealt with this question, which is your activity. You were given a mixture of 4 grams of ethanol and 25 mils of air, which was ignited at 25 degrees Celsius and standard pressure. A reaction occurs according to the balanced equation. So the balanced equation was given as usual. The question now was determined with the aid of a calculation whether all of the compound will be used up at the end of the reaction. So you have to understand the question here. The question is saying at the end of the reaction, are we going to be everything is going to be used up, or we're having something that is in excess and something that is a limiting reagent. Now, if the molar volume of gas at 25 degrees Celsius and standard pressure is 24,47, assume the air contains 25% oxygen. So, hoping you've done that. Let's go now to steps to say what are you expected to do. The first thing that you will do, you will use what you are given. Remember, you are given 4 grams of ethanol. So that 4 grams, you can use grams to calculate the number of moles. I always say this to learners that when you see the mass, you must think about the number of moles. So you can see that is your 4 grams, and then you have to find the molar mass of ethanol, which in this case will have been your 12 times 2, that was 24 plus 5, 29 plus 1, 30, and then plus 16. 30 plus 16 is 46. So that's where we got the molar mass of ethanol. And then you say 4 divided by 46, and you are able to get the number of moles of ethanol. Then that is the first thing that you expected to do, and you will get mark for that. The next thing that you are expected to do is that we are given the percentage here to say, all in all, we have 25 mils of air. Of that 25 mils, we are given that 21% of that, it is oxygen, 21% oxygen. So the air contains 21%, not the whole 25 mils of air is oxygen. Only 21% of that 25 is oxygen. So you must find the volume of oxygen first. How do you do that? You will say 21% of 25. So that will be the volume of oxygen. And you are able to get the volume of oxygen is 5,25 cubic decimeter. And then from there, already now you know that you know the number of moles of ethanol. Now you must find the number of moles of oxygen, which is the next step. Now you must find the number of moles of oxygen, and then you are going to use the molar volume that is given, which is the volume of oxygen, which is 5,25 divided by the molar volume. So when you say having the volume divided by the molar volume, you are able to get your 0,215. So you're able to get your 0,215 moles, and then that is your other mark again. So you see, of the 5 marks, you are working for them. The first mark was to calculate the number of moles of ethanol. The second mark was to calculate the volume of oxygen using the molar volume and the 21% that was given of the 25 cubic decimeter. So when you have done that, you have your 3 marks there. And then now you go now to the question, because the question was determine with the aid of a calculation whether all of the compound will be used up. Do you have anything that is used up, or do you have something that is in excess, or something that is limited or less? Let's check. We're going now to take the number of moles of ethanol versus number of moles of oxygen. So what you will do here, you are going to say, okay, according to the reaction, it is 1:3. 1 mole of ethanol reacts with 3 moles of oxygen, which means in this case, we're saying 0,087. This answer here, 0,087 is to 0,215. And all you have to do is to divide by 0,087 throughout, and you will find that the ratio is not 1:3, it is 1:2,5. Because if you take your calculator and you divide your 0,087 0,215, you divide it by 0,087, you will be able to get your answer, which in this case is 0,225, as we said in terms of that one. So you are able now to see that the ratio that we are having is 1:2,5. The ratio of those two is 1:2,5 instead of the required, which is 1:3. And then we are saying oxygen is the limiting reagent because we don't have enough oxygen. We have 2,5. We're expecting a ratio of 1:3. So you know that ethanol is in excess because oxygen is limited, is the limiting reagent. So it's important you are able to do such a calculation, and you are able to see what happens. Now, on the next question was, if the ethanol is not used up, calculate the mass in grams of ethanol that is not used. Remember, we were saying now the ratio is 1/3. When you multiply that by the 2,15, which is the one now, the 0,215 that we had for your oxygen, and then you are able to get 0,072, which is the number of moles of ethanol that reacted. So number of moles of ethanol that reacted is 0,072, and then how much is in excess? Always we are saying now we find the difference in the two to find the excess one, to say initially we had 0,087, we only used 0,072 because from here we learned that only 0,072 reacted, and then with no any doubt you are able now to get your answer to say in excess it is 0,015. And the question was, if the ethanol is not used up, calculate the mass in grams. So we have to use the number of moles to calculate the mass in grams. Now that will be our mass of ethanol is number of moles over molar mass. Always write the correct formula. And we know now that the number of moles of ethanol in excess, it is 0,015. You multiply that by molar mass of ethanol, and then you are able to get your answer, which is 0,69 gram. So you are able to get your answer there, and you collected all your 3 marks. I hope this helps you, and you are able to see that now this is how we go, because expect always when you are doing chemistry, it doesn't matter it is question 2, question 3, question 4, have some stoichiometric calculations, because they will always have 1 or 2 now and then. So it's important that always practice these stoichiometric equations in all the questions from question 2 to question 9. Know that stoichiometry will be there, and you must continue to learn and do it. Now, let's go now. That was November 2021. Now we're moving to November 2023. So we're going to 2023 now. We're saying, consider the cracking reaction below. So they told you that the reaction already, it is cracking. Remember, we are breaking down large organic molecules into smaller, most useful molecules. So here what is happening is that they're saying define cracking, which you'll definitely say is the breaking down of those large hydrocarbons into smaller, most useful molecules. So we are breaking C16H34. Remember, we said we'll form alkanes and alkenes, but in this time we're breaking it into three parts. So you got to understand that when we are doing this process, we can break into 2, we can break into 3, but as long as we are breaking the structure. So we had C16H34. I usually say to learners, this is just a maths question, because you know that you had 16 here, you took 6 here, you are left with 10, you took the 10, you took another 6 from 10, you are left with 4. Meaning that here we have 4 here. You must have 4. And already you have a 2 there as a coefficient, which says y must be 2. Because you know 2 times 2 is 4. So you will be able to see that, oh, y must be 2. So that we can have 4, because we have 6 plus 6, which is 12, plus 4 is 16. So you know that y must be 2. So that 2 times 2, it is 4. So I hope you understood that. Let's go to hydrogens. Now, when it goes to hydrogens, we had C6H14. When you take 14, you are left with 20. If my math is doing very well, it will say you are left with 20. And then for us to get an alkene here, we'll have XS12, C6H12. And then if you have 12 plus your 14, then that will give you something like your 26, if not mistaken. And then you will have your Z now. Remember, we're saying X is 12. It's C6H12. Now, this is an alkene. Now, the expectation is that now we have taken 12 plus 10, which is 22, 26. Then you're expecting the remaining to be on that particular structure, which must be your C4 H10, C4H8. So now in that case, if this is now you're having a 2 there, you will have a 4 there. You set there as your 4, and then you are able to see that, okay, we had 2 C2, which is 4 carbons, 4 plus 6, you are able to account for 16. Correct. And then let's go to hydrogens. We said is 14, is 12, and then we said 4 there. 4 times 2 is another 8. And then when you add them, they are able to give you the 34 there. So in real sense, that's what we're having. You had a C2H4 there, which is a good as good as C4H8. C4H8, which is butene in that order. So you're just taking the 2 as a common denominator there, as a common factor there. Then you are left with C2H4. So I hope we are moving together. So you were able now to crack this to say, okay, I know Y is 2. I know that X is 12. I know that Z is 4. So you got all that for that 3 marks. Now, compound C6H14, which is the alkane of the molecule. So they are saying this alkane now undergoes complete combustion. Remember, grade 12, according to our exam guideline, we do complete combustion. So we form carbon dioxide and water and energy. We don't do incomplete one where we have oxygen that is limited. Our oxygen will be in excess. So we do excess oxygen. Hence, they are saying complete combustion. Complete combustion simply means that we have oxygen in excess. So now you'll be having your C6H14 plus your oxygen there, forming carbon dioxide plus water. And we are saying here, learners, we're saying that now, this is what will always be formed, but don't forget, the purpose was not to form carbon dioxide and water. The focus was we wanted energy. We wanted energy. So we have energy as part of our product. Now we have to balance the equation. Remember, for writing this, you have 2 marks for the 1 mark for the reactant, 1 mark for the product. Now you are left with 1 mark for balancing the equation. And for balancing, we usually saying hashtag CHO. You will balance your carbons, you balance your hydrogens, you balance your oxygen. I want you to go with me here, Leonard, to say what you can do. You can write N in front of carbon dioxide. So N stands for the number of carbons. How much is N? Is 6. So you can write 6 there, which is your N. In front of water, you can write N plus 1. What is N plus 1? Is 7, because N is 6 plus 1 is 7. So you are able to get your 7 water there, 7 H2O. Now, you see now, if you check how many carbons on the left, there are 6. How many carbons on the right? 6. So the carbons are balanced just by you writing N and N plus 1. Don't forget, once you write the N in front of the carbon dioxide, you write N plus 1 in front of the water, you are able to balance the carbon and the hydrogens. Now you are left with oxygens. Hence we are saying hashtag CHO to say you will balance the carbon, the hydrogen, then you balance your oxygen. Now let's check how many oxygens do we have on the product side. I think you have 6 plus 2 is 12. 6 times 2 is 12. Please don't make a mistake. You don't say 6 carbon. It's not 6 oxygen here. It's 6 times 2. So it's 12 oxygens. Plus 7. This 7 is multiplying everything. So 12 plus 7 is 19. So you are able to see that we have 19 oxygens this side. But now we want 19 oxygens the other side. But we have a 2 there. So if you put 19 in front of oxygen, you'll have 38. So you need half of that. Hence, when you write your oxygen here, you will write it as 19 over 2. then you have the responsibility to multiply the whole expression by 2 because we don't want fractions here. So to balance it, you'll have 2C6H14 plus 19O2 gives us 12 carbon dioxide plus 14 H2O plus your NH. So that is a balanced equation. Another way of balancing the oxygen, as I conclude here, is to say you can write in front of oxygen 3N plus 1 over 2. As well, that will give you the number of oxygens that we have. Remember, you are saying 3 times 6, which is 18. 3 times 6 is 18, plus 1 is 19 over 2. Then you are able to get 19 over 2. Then you are able to get your 3 marks there. I'm hoping that I've assisted you in how to go about balancing these equations. But we are saying practice, practice, practice. Do all of them. There are only 8 combustion reactions we do in grade 12. So just take from methane to octane. Do all of them, balance all of them, use all the methods that we're showing you in doing these ones. I hope this has helped you and it will help you to move forward. Now, still in 2023, they say to learners, consider the equation for reactions 1 to 3 below. Consider the equations for reactions 1 to 3 below. A and B represent organic compounds that are positional isomers. They represent positional isomers, A and B. Hey, learners, you see these questions, if you don't read them properly, you will make mistakes. Because you can look at A plus B and you think these are 2 products that are formed in the reaction. Let me explain that so that we move together. I don't lose you here. A and B are one is a major product, the other one is a minor product. So we're saying there are 2 types of product that can be formed when we add HCl to this molecule that were heavy. There are 2 products that can be formed. What do you mean, sir? I mean, the best thing to do is to draw the structural formula first. You say, okay, CH3, CH2, CH. You can see already that there must be a double bond there. Hence, it's a CH, another CH, and then a CH3. This is the structure that we are given. And if you check, we have 1, 2, 3, 4, 5. We have 5 carbons. So this must be an in carbon number 2. So it's a 2 in, and 5 carbons means pent. So it's a pent 2 in. So we're given pent 2 in there. And we are going to add HCl. We are saying we have 2. Maybe I must write HCl as a structural formula with showing the bonds there. The HCl there, we are saying now we have 2 options. One option is where the hydrogen will go to this carbon number 2. Another chlorine will go to this carbon number 3. The other option is where the hydrogen, the hydrogen will go to carbon number 3, the chlorine to carbon number 2. So there are 2 options. A plus B is a combination of chlorine going to carbon number 2 and chlorine going to carbon number 3. So we have 2 answers that can be formed there. Hence, we are saying they are positional isomers. A and B are positional isomers, which means the other one is a 2-chloro. The other one is a 3-chloro. 2-chloro pentate, the other one will be 3-chloro pentate, because when you add HCl, we are breaking down the double bond, we are forming a pentane now. I hope you are moving with me. Now, they go further and say, these products that are formed, A will be taken, and we are going to add to use water there, and A will, if we add HCl, we are going to form, let me write the product so that we move together. I don't leave you and talk to myself, and I want you to move with me. Now, remember, we had the option where the chlorine was in carbon number 2 here. The chlorine is in carbon number 2 there. So that is the other option. The chlorine is in carbon number 2. The chlorine is in carbon number 2. The other option, we are saying the chlorine is in carbon number 3. So for the other option, I can write same 5 carbons, but I'll put chlorine in carbon number 3. Hence, we are saying these are positional isomers. These are positional isomers, and we are moving with them like that. These are our positional isomers. So we have them, a 2-chloro and a 3-chloro. Now, if you check now the product that is formed from A, the OH is in carbon number 2, which means we know that the haloalkanes, they undergo substitution. The haloalkanes, they undergo substitution, which means we substituted the Cl in carbon number 2 with the OH, which means this 2-chloropentane is A. 2-chloropentane is A, which means B will be 3-chloropentane. I hope you are moving with me. 2-chloropentane will be our A because we're going to replace the chloro with the OH in carbon number 2. So hence we are saying the structure of A will be the one where the chloro is in carbon number 2, which is 2-chloropentane. I hope we are moving together on that one. Now we're going to take the product that is formed in reaction 2. It's going to undergo another reaction again. We're going to eliminate, which is dehydrogenation. We're going to remove water and it undergoes the reaction. So you were able to analyze the whole question before you start answering, because the issue and the problem that our learners are having is when you don't understand the analysis of the problem. So I hope you got you understood to say we have two types of answers that can be formed. It's a 2-chloropentane or 3-chloropentane, and we call them positional isomers. Obviously, they will be asked what are positional isomers. Then you will say these are organic molecules with the same molecular formula but different position of the substituent. In this case, chlorine is our substituent. So it's a different position of the substituent. But the exam guideline talks to three things to say it's a different position of the substituent, different position of the side chain, or the functional group. So in this case, it's a substituent. So you will say define positional isomers. You will say these are organic molecules with the same molecular formula but different position of the side chain, the substituent, or the functional group. Then you get your 2 marks for 4.2.1. When you go to 4.2.2, the question was what type of reaction is represented by reaction 1? What type of reaction? Obviously, we had a double bond, we had an alkene, so it must be addition. So you will say addition. I know others will say hydrohalogenation. We'll still mark it correct. But when we say what type of reaction, we're referring to the general type of reaction, which in this case is addition. Because we can ask again and say what type of addition reaction, then you will say hydrohalogenation. Now, structural formula of compound B. So they are saying draw structural formula of compound B, and we said compound B is when the chloro is in carbon number 3. Hence, you will draw the second structure there, which is 3-chloropentane. And you are drawing that structure for 3 marks. And then they are saying formula of X. Remember now we replaced now. We had HCl there, we have a Cl there, we replace the Cl, water is like this, it's O with that, and then the OH is this one that replaces the Cl here, and the Cl will be now attached to the H, and X will be HCl will be our X, so you are able to write HCl there for X, hydrochloric acid. And then they are saying for reaction 3, what are the inorganic reagent for reaction 3? Remember, for this type of reaction, when I'm emphasizing again that when we have water in a reaction, whether water is a reactant or water is a product, we said in our syllabus you will see that it's substitution, only in substitution where we have water and we are not using sulfuric acid. But if you check now, when we are doing elimination, we are using sulfuric acid as a catalyst. When we are adding water, it is sulfuric acid that is a catalyst. When we are doing esterification, it is still sulfuric acid that is a catalyst. So you are able to remember that, okay, where there is water, sulfuric acid is around, with the exception of substitution as far as these reactions are concerned. I hope that will help you a great deal to remember the reaction condition, to say it must be sulfuric acid that we are using here, so that the reaction is we are able to eliminate the water there. Now, when that same question paper continues, it says now consider the equations for reactions 1 to 3 below. Now they are saying compound A can be converted directly. Compound A, which we said is 2-chloro pentane. Don't forget that. Let me write it here for you so that you remember this is compound A. So they are saying compound A can be converted directly to compound A can be converted directly to the product of compound 3, to this one, to that product directly. It can be converted. Compound A, 2-chloropentane, can be converted to butan, but2-ene. So they are saying that can happen. So now they're saying beside it, write down the reaction condition needed for this convention. So when you want to remove the Cl and the hydrogen there, which reaction condition are you going to utilize? So what are you going to use as the reaction condition, which in this case now you are removing an acid. HCl is an acid, so obviously for removal we said use CEDS, concentrated for elimination. So you will need concentrated sodium hydroxide, so that you know the reaction between an acid and a base will give us salt and water. So this reaction definitely will have an alkene, will have salt, which is sodium chloride, and will have water, which is a nice dehydrohalogenation reaction. So you have to say that the reaction condition, write down the reaction condition, is that we must use concentrated sodium hydroxide and we must use heat, but this one we needed only one. Write 2 terms that describe this type of reaction. So this type of reaction, it is elimination. What type of elimination? Dehydrohalogenation, because we're removing that. And you got your 19 marks in 2023. Without any wasting of time, let's move. Remember, I told you that today we are focusing on problem solving. We are doing previous question paper, so you can see how these questions are asked. Now, in May, June 2024, you were given in an experiment a test tube containing methanol, propanoic acid, and the catalyst is heated in a water bath. Very much important there to say no, we are using water bath there. The reason being that you are dealing with alcohol here, then definitely alcohol is flammable, and then that is going to give you you are going to have to have problem. Hence you can't heat the alcohol directly there, because it is flammable, and then you are taking some precautions there, to preventative measures to deal with that. Now, name or formula of the catalyst. So you see that they gave us methanol, they gave us propanoic acid, they gave us a catalyst. So you are able now to see that, okay, now this one, our catalyst now will be sulfuric acid, and this type of reaction we call it esterification. And we said we are doing this to take precautions in order to ensure that we don't expose the alcohol to direct heat, so that we are using the water bath, because it is flammable, and then we are doing that as a protective measure. And then they were saying as well, you must show the balanced equation for this reaction using structural formula. So the expectation is that you must draw methanol, which is 1 carbon. Methanol is 1 carbon. And you must draw propanoic acid, which is now 3 carbons. Prop is 3 carbons. So you'll have structure like this, and then that is your propanoic acid. And then when you're having this, they are saying, okay, the balance equation for this reaction using structural formula. So you see that now this is what is going to happen. We are removing the OH from the carboxylic acid. We are removing the OH from the carboxylic acid. We are removing the H from the alcohol, and that is going to form water, H2O. Now we're able to form water, and then what is left? We just want to, the expectation is very simple on your side. It's just to write this structure without water. So you just draw everything the way it is. So I'll draw this hydrogen. I will draw the carbon that follows. The O, there's no more H because the H went to the water. The O, I wrote it there. And then I'll make a bond. that brings to this carbon with a double bond. So I'll have a C double bond O there, I'll have a CH2, and I'll have a CH3. So you are able to see that, and then that is your ester that is formed, and that is what we call esterification. Now, how do you name this? Remember, the alcohol becomes the alkyl group. So methanol will become methyl. The acid, remember what the acid did? We had the oxygen here that was with the methyl, but now the propan, this propan ate the O. Hence we are saying methyl propanoate. You see, the O was eaten by the propan. This propan here ate the O of this one, so that this one becomes the methyl. So you can see that we're having methyl propanoate as an ester that is formed, and that is the name of the product, which is the question in question 4.1.5. I hope you got that. Now, question 4.2, they say now compound A is a 6-carbon branched haloalkane. So they told you that it's branched. So it's important, learners, that as you are doing questions, don't do questions that don't have branches only when you are dealing with reactions. Hence, we are moving towards the direction where we have branches in the structure, so that we can start to do even a little bit challenging questions that will at least intrigue your mind to say practice, 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 so that come exam you will be laughing with the paper because you will have prepared well. Now we are saying this one is a branched haloalkane. That is our first one. It's not straightforward, it's a branch. Now, it's used in a 2-step reaction to prepare compound C. So you see those preparation. But they told you that reaction 2 is an addition reaction. You see, if you miss this statement, this question is going to be impossible for you to answer. That's why I was saying you must read, and you must read with understanding. Because when you say reaction 2 is an addition, so the question is, what did we add in reaction 2? Because if you check here, you will see that we don't have any foreign atom. We don't have any foreign atom, if I can use that word to say, we don't have any atom like chlorine, bromo, OH, and what. We have an alkane here. We're having an alkane, and now it tells you what was added. Already, you know that what can we add to form alkanes, and you know we only add on alkenes. So we're saying this is an alkene, and we're going to add on this alkene to get an alkane, and that can only be hydrogenation. So already this statement is telling you that we have an alkene here, we're going to add hydrogens, so that is hydrogenation. Remember, for hydrogenation, we're saying the catalyst is platinum, palladium, or nickel. Don't forget those reaction conditions. I'm always emphasizing them so that you don't forget these reaction conditions. Now, we already, you see that, okay, we have an alkene here, but now what is the name of that alkene? You will only know it when you look at the compound C there, the product there. The product is telling us that we added. And if you check, by no ways we could have added on this one, because there is no hydrogen. We're adding 2 hydrogens. There is no hydrogen on this carbon. So we can't add here. We didn't add here. There was no addition there. There was no addition there. The only place that you can add is here, because there are 2 hydrogens. Remember, we're looking for 2 hydrogens. So between this carbon and the other 3 carbons, there are no 2 hydrogens we can find. We can only find them between carbon number 3 and 4 in this case. But in the previous question, it was carbon number 1. So it means the addition happened here. The double bond was on the first carbon, which is CH2. Compound B is CH2, which is the first carbon, and CH, so there was a double bond there. And then we had CH3 on this carbon, and another CH3 and another CH3. So you are able to see that this is the structure that we had as compound B, and we're able to add so that we have CH2 and CH3, because we added 1 hydrogen and another 1 hydrogen. I hope that helps you to be able to see how did we come about doing that. These are question papers that are readily available on the internet, on the department website of the DBE. Just go there and look for these question papers and practice them and do them and do them. And I'm telling you, if you practice as many as you can, you will be able to answer all these questions. Now, already you can see that, okay, we had, now you can as well go back to say, okay, this was formed from reaction 1. What did we have in reaction 1? We had a haloalkane. So you will be able to see that, okay, we had a haloalkane as well there. It was the CH3, the C, and the CH3, always we have that. And then we had a haloalkane, which now you will have the Br there. You will have the Br there. You can have CH, you can have CH2 or CHBr. So we had two options. Either the Br was in carbon number 1 or in carbon number 2. That is the other option that we will see as we move with the question. So, buddy, this is your expectation that the haloalkane in compound A looked like this. You just didn't confirm the position of the bromine. But because the double bond is in carbon number 1, let the bromine be in carbon number 1 there, so that we don't have issues. So you are able to see that, okay, compound A will have been 1 bromo in carbon number 1 with a bromo, 2, 1, 2, 3. In carbon number 3, we have 3,3 dimethyl. So this is structure: 1 bromo, 3,3 dimethyl. Then how many carbons? We said we have 1, 2, 3, 4. So it's butane. You see, that is the structure that we had when we started. What did we do? We we eliminated the 1 bromo. We formed the alkene now. 2,2 dimethyl but 1-ene. 2,2 dimethyl but 1-ene. That's what was formed as compound B. Put 1-ene, and then you, from that 2.2 dimethyl but 1-ene, you added the hydrogens, and then what did you get? You get 2,2, this structure that we're having, 2,2 dimethyl butane. So you can see the transformation from 1 bromo 3,3 dimethyl butane. You moved now to 2,2 dimethyl but 1-ene. You moved again, same structure, 2,2 dimethyl butane. So you are able to see that you are able now, as you move with the reactions, you are able to do all of those. Now, compound B, don't forget from the previous question, we said compound B was this one, which is an alkene now. Our alkene, which is now 2,2 dimethyl but 1-ene. Let me write it here. 2,2 dimethyl but 1-ene, that is the one that we are moving with. So they're saying compound B, which is our alkene, used in two-step reaction to prepare compound A. So they want to compare to form compound A using compound B. Remember, compound A was a haloalkane. Now, if you check the name or formula of the catalyst used in reaction 3. So if we check reaction 3, we are having an alkene, which is compound B, this one, 2,2 dimethyl but 1-ene. Now, we already have added H2 on the previous question. We only do 4 addition reactions. So I want you to go with me so that we understand one another. The other one that we do is called halogenation, where we add Cl2, Br2, I2 or F2, usually Cl2 and Br2. That is the first halogenation. It doesn't even have a reaction condition. It is a spontaneous reaction. The second reaction is where we add hydrogens, which is what we did in the previous question. Hydrogen, we call it hydrogenation. So we said the catalyst there is platinum, palladium, or nickel. The third option now, which have reaction condition again, is when now we are adding water. Remember, when we are adding water is hydration, because when we are adding ACl, we said it's hydrohalogenation. We said the reaction condition is that no water must be present. So in this one, there is the catalyst that he used, and I'm saying there are only 2 reactions that we do under addition that have catalyst. It is hydrogenation, that using platinum, palladium, or nickel, or hydration that uses sulfuric acid. So you're able to see that we're only left with one catalyst here, which is sulfuric acid, because the other one was used on the hydrogenation that side. So you can see that the catalyst used would be sulfuric acid, and the IUPAC name now will be that we are adding the water, we're getting the alcohol now. Where will we add? This is very much important, because you are having put one in, which you must focus on there to say in carbon number 1 we have a double bond, so that will be your put one in, and then you got the structure. And then in carbon number 3 we said we have 2,2 dimethyl, so you have a methyl there and another methyl there. Then you have your hydrogens here like that. So when now you are bringing your water, you are going to now use for addition, you are using Markov-Nikov's rule. The hydrogen will go where there are many hydrogens. So you are expecting that the hydrogen will go to carbon number 1, this carbon, and the OH will go to carbon number 2, meaning that now the structure that we have formed will be the same, but it will be 2,2 dimethyl, that doesn't go anywhere, but the OH is in carbon number 1, so it will be butan to all, because the oxygen is in carbon number 1. So very important, that one. The type of reaction represented by 3, obviously this is an alkene, so it must be addition reaction. Now the type of alkane represented by compound A. Now as well, very much important, remember we're having 4 carbons, and then we're having the OH in carbon number 2, and then we're having the methyls here, 2,2. Don't forget that 2,2. Wherever you go with 2,2. You don't leave it around. So you are having that as your 2,2 dimethyl butan to all, and then you are going to replace now. You are going to replace, because this is a substitution reaction. You want to form a haloalkane. You are going to replace the OH with the HCl now. You know now that, okay, with the Cl. So you want the chloro will be in carbon number 2. And if the chloro is in carbon number 2, will stay. The carbon that is bonded to the Cl will be bonded to 2 other carbons, which is now a secondary haloalkane. To be a secondary haloalkane, because the carbon that is bonded to the Cl, because the Cl will be in carbon number 2, the carbon that is bonded to the Cl is bonded to 2 other carbons. Or you will say the carbon that is bonded to this to the halogen, to the Cl, is bonded to one hydrogen. Then that qualifies as well as a condition for it to be a secondary. And with that, you will have got 20 marks. I hope we're inspiring you to do as many questions as possible as you prepare yourself. I always want to finish with this one, which is our last year's problem, which was a big problem to our learners. So we're saying, let's practice, let's be ready, understand the science, leave the issue of cramming and all that, understand the science behind. Remember what we said. We said when we are having alkanes, haloalkanes, and alcohols, they have 2 types of reaction they can undergo. They can undergo substitution or elimination. So always when you see you know that the reaction is either substitution or elimination. So when you see those, you will know that it's either substitution or elimination that these 2 will undergo. But don't forget, with alkanes, they undergo as well oxidation or combustion. So I always want to emphasize that so that you don't misquote me. Now, elimination, it includes cracking, which is breaking down a chemical process whereby large organic hydrocarbons are broken down into smaller, most useful molecules. That is what we refer to as cracking, which is definition for 4.1 there, to say you must be able to define cracking, which is one of the, I think 28% of learners last year were able to define cracking, and majority of learners failed to. But I know that is not your story. You will define it, and you will define it correctly. Now, the main thing is analysis of the question. Leave the questions alone. Analyze the diagram, because once you analyze the diagram, we are done. You make your own memorandum here, and then you will be able to enjoy the subject. Now, let's look at this. We're given organic compound, which is U. U is given there. and then that U is being divided into two. It's been broken down into two, into organic compound W and organic compound T. Organic compound T has 4 carbons and 8 hydrogens. So you know CnH2n. That's the general formula for alkenes. It means organic T is an alkene, and that alkene can only be but1-ene or but2-ene. Remember, we have those two positional isomers of butene. So you know that T is either but1-ene or but2-ene. But now, if you look at reaction 2 now on the left here, you will see that we are having CH3, CH2, 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 Br. How many carbons? You are having 4 carbons. How many hydrogens? 9 hydrogens and a Br. So you are able to see that we have C4H9Br. Because there is something that fascinates me these days is when you use the molecular formulas to answer these questions. So immediately when you go with them, I'm telling you, they will just do something for you, and they will make you even enjoy as much as you can in terms of this question. So I'm going to demonstrate that to say how can I use molecular formulas to answer this type of questions. Now, without any wasting of time, so now we have 4 carbons. We have 4 carbons there. So it's a C43579 with H9Br. That's what we're having there as our as a product for reaction 2, C4H9Br. But now we have learned that, okay, cracking process, because they told you that reaction 1 is a cracking reaction. So you know we're breaking down a large organic molecule. That organic molecule was having 8, because we have 4 here, we have another 4 here. So you know it was a C8. That one you know for sure, that U has a C8. But now you know that we have an alkene here, which is C4H8, which means that W is an alkane. In this case, it will be C4H10. And if you add those two, you will get C8H18. So you're able to see that, okay, we're having butane here. And then that butane, what happens? How many carbons do we have? We still have 4 of those carbons that we have there. But now we had 10 hydrogen in butane. But when you look at the product of reaction 2, we now have 9, which means we have replaced 1 hydrogen with a Br. Which reaction replaces? It is substitution. So you are able to see that this must be substitution reaction. So this must be substitution reaction. So you know that was a substitution reaction. And what type of substitution? It was halogenation. And ask yourself, what is the reaction condition for this type of halogenation where we are using Br2 or Cl2? You know, we said UV, we said sunlight. Sunlight is a reaction condition for this reaction. For every reaction, ask yourself about the reaction conditions, because you are always answering even the questions that you have not been asked before. You can see here we're having a haloalkane. You know, haloalkanes, they can undergo elimination. So when you have a C4H9Br, you can eliminate there. Maybe for you to eliminate nicely, draw the structural formula so that you don't have problems of you eliminating. Draw the structural formula so that you can see clearly, because sometimes you are seeing but you are not seeing clear. So let's say you are having Br there, and then your H and your H here. When you now want to substitute, definitely you'll remove that one and this one. So you'll get but1-ene here. You'll get but1-ene. And remember what we talked about. We say for this type of elimination, you are going to use concentrated. Remember that concentrated is for elimination. So it's concentrated sodium hydroxide. So you are going to do that, meaning that you will form an alkene with a sodium bromide, salt and water. An alkene, salt and water, which is dehydrohalogenation. When you do dehydrohalogenation, you're able to form your alkene, your salt, and your water. And then easily you have your alkene there, which in this case we are saying is but1-ene, and but1-ene, you got your but1-ene there. Remember, we had another butene here, but we don't know whether this one is but1-ene or but2-ene. But the science will tell us what will happen. So up to here, you have arrived there, and then you can be able to draw the structure of but1-ene, because definitely you'll be asked to draw this type of structures. You know the double bond is in carbon number 1, and then that is but1-ene for you, that is compound R. But1-ene as your compound R, and then you're able to do that science. Now, the questions on this page is the product in reaction to a primary, secondary, or tertiary alkyl. Give a reason for your answer. We said it's primary because the carbon that is bonded to the halogen is bonded to one other carbon. Now, if you move, write down the structural formula of compound W. We said it's butane here, C4H10. So you just write butane, which is what I've done on the other page, but I can do it quickly. You just write your 4 carbons, C4H10, and then you show all the bonds. And then you go to 3 marks there. You are rich. Molecular formula of compound U, we said it's C8H18. You see, you are collecting your marks there. You have 3, you have 1 mark there, and then you are doing well. And then reaction for reaction 2, now on this one, reaction 2, which I've done already, the name or formula of the inorganic reactant. So now we already said that we are going to use Br2 here for substitution. We're going to substitute 1 hydrogen with a bromine, so it will be Br2 as our inorganic reactant. The type of reaction, is it substitution, addition, or elimination? We said this is saturated, forming saturated. That is triple S. That is substitution. And then you are able to get your mark. Look at how you can collect these marks if you've done the right thing. Write down the type of elimination in reaction 3. Remember, we're removing HBr. So it's what? The elimination is dehydrohalogenation. Or others, creative ones, they will say it is dehydropromination, which is correct. We'll mark it correct. So it's dehydropromination. And then you are able to get that. And then last but not least, they are saying here compound in R and T. R and T. Remember, we have done compound R in the previous slide, where we said it's but1-ene. So that information helps you to say, okay, if this is but1-ene, it will mean that this is but2-ene. That's the meaning of it. They are positional isomers. That's what the statement said. Now, the inorganic reactants shown below are available for reactions 4 and 5. So we're doing the last 2 reactions. Now, the balance equation for the reaction 4 using structural formula and the correct inorganic reagent shown. So you have but1-ene there. So you are saying, okay, 1, 2, 3, 4. That is our but1-ene. And then for reaction 4, ne? And then what can you use? What can you add there? If you add Br2 on this structure, you are going to get 1,2 dibromobutane. And we don't do dehalogenation. So it means you won't finish your synthesis. So it's important that you know that, hey, this one is going to cause us problem. We have used it in reaction 2 anyway, this one. We have used it here when we're substituting. Now, HBr. If you add HBr, you know, plus HBr is going to be hydrogen will go with the amino hydrogen, the Br will go there. So you're able now to write your product, which will be now having like that with the bromine in carbon number 2. So you have 2-bromobutane as your product. 2-bromobutane as your product after you have added the HBr there. And then they gave you 5 marks for showing all those structures. So I don't know, it will be 2, then 1 for that, 2 for the product, and all that. You have 5 marks, you are rich. Now you are having your 2-bromobutane. Now you are having your 2-bromobutane, the bromo carbon number 2. And then the last question on that one, before you name, the last question was second from last, was the balance equation for the reaction 5, which is this reaction, which is forming now a double bond, which is now elimination. So you know, when you have to eliminate, you are eliminating HBr. So you are eliminating an acid. You are going to use a base concentrated. sodium hydroxide for elimination. We've done such types of reaction, and then you are going to eliminate you see that the double bond will be in carbon number 2. That proves that this one will be put 1 in. So you're just showing that to say, okay, I'm going to eliminate there, because according to Zaitsev, we can't remove the for the major product, we can't remove the hydrogen from these richest carbons. You will remove the hydrogen from the poorest carbon, the carbon with the less number of hydrogen. Hence, you will remove this hydrogen and this bromine there to form a double bond there. So you will be able to put 2 in. So if now it's a balance equation, you will show the equation, and what is the name of compound T, it will be put 2 in, and you will have got your 22 marks. Now, I would like to say, anyone who has never made a mistake, has never tried anything new, we are saying the other class, we are going to have our next class on the 14th. We'll be doing a revision of question 2 and question 3, which is your nomenclature and your physical properties. So till we meet again, thank you very much.